Let us look at some more examples of testing continuity of functions. So we'll have a compound function here, piecewise defined function, and we want to see what happens where x is equal to 0. So let's first see what happens with this function. Where x is equal to -1, something strange happens. Where x is equal to 1, something strange happens. Now where x is equal to 0 falls within this interval. So everywhere around x equal to 0, my function, so at x equal to 0, this function is just the quadratic function x squared. And we know a polynomial is continuous. So the limit as x approaches 0 of f of x is going to be 0, and f of 0 is going to be 0. So those two are equal. So it's easy to look at this one to conclude that f is continuous at x equal to 0. But now let's look at a bit more of a challenge. What happens when x is equal to 1? All right, let's first see what is f of 1. So what is this function value at 1? So x is equal to 1 is this middle function, so it's 1 squared, which is 1. Now we must look at the limit, but because there's two different functions at play here, we need to look at from the left and from the right. So the limit as x approaches 1 from the negative side of this function, and the limit as x approaches 1 from the positive side. We have to look at both of them. So as x approaches 1 from the negative side, its value of x smaller than 1, so we're going to look at x squared. So that is 1 squared, which gives me 1. As x approaches 1 from the positive side, its value of x larger than 1. So it's x minus 1, so it'll be 1 minus 1, which is 0. So now we see that from the left and from the right, it's not equal. So our first conclusion, we don't jump to the end, our first conclusion is that the limit as x approaches 1 of f of x does not exist. So then I can conclude that f is not continuous at x equal to 1. Let's just take a look at what type of discontinuity it is. In the previous video, we highlighted the types of discontinuity. This is the case where the function value can be found, but the limit from the left is not equal to the limit from the right. So this is an example of a jump discontinuity. Let's look at the next one, where x is equal to -2. And we've seen this function before. Now, f of -2, x is equal to -2 for this middle function. So that'll be -2 squared minus -2 plus 2. So it's 4 plus 2 is 6 plus 2, so that value is 8. All right, the next one, now we need to go look at the limit from the left and the limit from the right. So if I look at the limit as x approaches -2 of f of x from the left, that will be function values of x that are less than -2, so then we're in this part. So that'll be 2 times -2 over -2 plus 1. So it's -4 over -1, so that's 4. We already see there's trouble, but let's see it through to the end. The limit as x approaches -2 from the positive side of this function. So from the positive side, we're looking at values of x larger than -2. So that'll be -2 squared minus -2 plus 2, which gives me 8. So again, like the previous example, the limit as x approaches -2 of this function does not exist. So this limit doesn't exist. So again, we have a jump continuity because the limit from the left and the limit from the right are not equal. So we can conclude then that f is not continuous at x equal to -2. All right, so let's look at this one. Same function, what happens where x is equal to 1? Now, the first step is finding f of 1. Well, x is not equal to 1 anywhere. 1 is not in the domain of the function. So f of 1 is undefined. We can stop right there. We can stop right there and see, well, f of 1 is undefined. It doesn't exist. So f is cannot be continuous at x equal to 1. But for the type of discontinuity, let's just see what happens if I look at the limit from the left and the limit from the right. It's not needed if I'm simply testing for continuity, but we want to look at what type of discontinuity this is. So as x approaches 1 from the negative side, its values of x smaller than 1, so we've got 1 squared minus 1 plus 2, so that gives me the value 2. The limit as x approaches 1 from the positive side of this function, larger than x, so it's 4 times 1 minus 2. That's also 2. So the limit does exist. So the limit as x approaches 1 of f of x is equal to 2. It's just not equal to, I don't even have to say that because I've already said that f of 1 doesn't exist. So that's why it's not continuous. But this shows us what type of discontinuity we have. We've got a removable discontinuity because the limit exists, but at 1 the function doesn't exist. So that is how we test for continuity. So we don't always know what it's going to look like without a sketch, but we have to just go through the steps systematically to test where a function is continuous or not.